evening, students. In this session, let us see about our short answer questions in our second year paper. In the last class, we have seen very short answer questions and how you need to answer such type of questions. In this session, let us see about this 4 marks questions that are short answer questions. So let us start our session. So from the short answer questions, they carry 4 mark in your board exam. You need to think and answer for each and every step which you are answering in the question, because they carry 4 marks. It means the statements which you give most appropriate, those statements are allotted the appropriate marks. So don't exceed your answer after the topic. What is necessary to the required question, you need to mention it clearly in that answer. In such a way, you can get 4 out of 4 marks from the short answer questions. Let us see a short answer question like this ferromagnetism, which is from the solid state. You can expect this type of question. They are asking to explain ferromagnetism with suitable example. It means you need to elaborate this ferromagnetism. What is meant by ferromagnetism? In which type of substances you can see this ferromagnetic properties? See, first you need to answer what is ferromagnetism. What is ferromagnetism? Some substances containing more number of unpaired electrons. As we know how magnetism is exhibited by unpaired electrons. Similarly, for this ferromagnetism also we can expect unpaired electrons presence. They are strongly attracted, very strongly attracted by the external magnetic field. Since they are very strongly attracted, they exhibit the property of ferromagnetism. So what happens in these substances? What happens in these ferromagnetic substances? The magnetic moment in individual atoms are aligned in same direction. It means, for example, if the magnetic field is in this direction, before applying the magnetism, all the electrons will be in a random way in the substance. After applying this magnetic field, that is this external magnetic field, what happens? All these electrons will be aligned in the direction of the magnetic field, such that that substance can exhibit the property of ferromagnetism. Got it? You need to elaborate in that way. Those types of substances are called ferromagnetic substances. Be careful while writing examples. Write the correct example. So in ferromagnetic substances, the field strength, that is the magnetic field strength, that is the field strength is very stronger. It means you can exhibit such type of ferromagnetism in iron, cobalt and nickel. These substances can be converted into strong magnets in presence of the external magnetic field. So this is the answer for this question. You can also expect a question from the solid state, that is from tetrahedral voids. What is meant by tetrahedral void? What is meant by octahedral void? Let us see. First, you need to know the definition of a void. So what is void? Void is nothing but the space present in between the unit cells. You can see the space here, the empty space here, that is known as void. See the definition of tetrahedral void. What is tetrahedral void? The second layer spheres over the first layer arrangement of the spheres. See, we have, suppose, example, assume it in a 3D way. We are placing spheres in layers, right? If we place spheres in this layer and spheres in this layer, got it? What happens? All the triangle voids of the first layer are covered by the spheres of the second layer. It means triangle is formed by 3 points, right? So here the void formed between the triangle layer, those type of voids are known as tetrahedral voids. And what are octahedral voids? Here it is in triangular way. Here octahedral voids are surrounded by 6 spheres. For example, you can see here also spheres are placed in layers. These are 4 spheres of 2 layers. These 2 comes in 1 layer and these 2 comes in 1 layer, and we have one more sphere on the top and one more sphere on the bottom. Assume in a 3D way. The space formed in between these spheres, this is known as octahedral void. So first you need to know what is a void, and then you need to explain how a tetrahedral void is formed and how an octahedral void is formed. So in this way we can see the octahedral void. So this type of questions you can expect. And next, a question like a problematic question, like how many lattice points are there in one unit cell of face centered tetragonal lattice? What is the question? How many lattice points? We need to measure how many lattice points are there in face center. So for face center we have some notations. It means with that dimensions we can measure how many lattice points are there. For example, if we see in face centered tetragonal unit cell, how many faces are there? Number of faces, there are 6 face centered atoms. For example, if we assume a face centered cell, you can see there are 6 faces. They are shared by half of the atom per unit cell. It means one atom is shared by 2 FCCs. So it means one FCC is having half of the atom per unit cell. It means it is multiplied by half of the atom. 6 faces of the atoms, centered atoms, are multiplied by half of the atoms per unit cell. For example, if you assume this is one face of the unit cell, it is having in this way half parts of the unit cell. So that's why we are taking half here. Completely we will get 3 atoms. All the 6 faces are shared by 3 atoms. So 6 into half, that is 3. Therefore the number of lattice points is sum of the atoms present in the FCC. We have one complete atom and 3 face centered atoms per unit cell, that is 1 plus 3, that is equal to 4. Completely we have 4 lattice points in FCC. You can expect these type of questions also. And next, from solutions, you can expect a question like Henry's law. Simply state what is Henry's law and explain what is the formula in this Henry's law and what are the chemical terms present in this law. So what is Henry's law? At a constant pressure, the solubility of a gas in a liquid, that is directly proportional to the partial pressure of the gas. That is the partial pressure we are applying on the gas above the surface of the liquid. So this is, remember this, at constant pressure the solubility of a liquid is directly proportional to the partial pressure of the gas. We are applying it on the surface of the liquid. If you represented it in a mathematical formula way, that is the partial pressure P is directly proportional to mole fraction of the gas. In order to remove this proportionality constant, we are adding a Henry's constant, that is KH. So completely the formula is P is equal to KH of X, where KH is the Henry's constant and P is partial pressure and X is mole fraction of the gas. And next question, a question will be asked in this way also. This is a direct question. What is meant by Van 't Hoff's factor? One of the important topic in this chapter, solutions, and they are asking how it is related to alpha in case of binary electrolyte, that is 1:1 in the ratio of 1:1. So first, what is the question asked? What is Van 't Hoff's factor? So define Van 't Hoff's factor. It is defined as the ratio of the observed value of the colligative property to the theoretical value. See, this is the formula where it is denoted by I, and this I is equal to experimental value by calculated value of these 4 colligative properties. And what is alpha here? Alpha is nothing but degree of dissociation. We need to calculate here degree of dissociation. Solute dissociation or ionization process, that is alpha. We need to find how alpha is related to I. For if a solute on ionization gives n ions and alpha is the degree of ionization for that solute at given concentration, we have how many total number of particles? 1 plus n minus 1 of alpha. This n minus 1 of alpha are the dissociated particles. This 1 minus alpha on reacting on reversible reaction, that is they form n alpha products. That means completely we are having 1 minus alpha plus n alpha products. From that we will get 1 plus n minus 1 of alpha products. Here we need to calculate I value. So this is the experimental value which we got, but actually total number of practicals, theoretical value will be 1. From this, if we find alpha, that is degree of dissociation or ionization, we will get value of I minus 1 by n minus 1. Here the concentration is given as 1:1 for a binary electrolyte. So for binary electrolyte, what we are doing, this is the ionization process for this complete for this binary electrolyte of 1:1 ratio. And next, for solute of association process, for association, it means the reverse of this process, we can also calculate the value of this Van 't Hoff's with the help of this Van 't Hoff's factor. That is, if there are n moles of A molecules, they combine to give A. It means it is represented in this way: n moles of A combined to give A molecules of N. If alpha is the degree of association at the given concentration, then we get 1 minus alpha is equal to alpha by N. So from this we can get I value as 1 minus alpha plus alpha by N of 1. Similarly, with the help of this formula we will get this value. From this, if we determine what is alpha we will get 1 minus I of 1 minus 1 by 1 N. Simply this is the derivation. First understand the question, what you need to define and how you need to relate, so that you can answer clearly. And next, from electrochemistry, we can guess this direct question of Nernst equation. Very important, very important question, Nernst equation. And this question is extended like, write the equation for an electrode with electrode reaction. We have a reaction here. So for this question, first we need to explain what is Nernst equation. So when this Nernst equation will be used, and what is Nernst equation? The electrode potential at any concentration measured with respect to standard hydrogen electrode. See, for at any concentration, this is the electrode potential we need to calculate at any concentration with the help of standard hydrogen electrode. The equation given is known as the Nernst equation. Thus, this Nernst equation is E is equal to E naught plus RT by NF ln of concentration Mn plus. So this is the Nernst equation. And we have an equation given in the question, that is Mn plus N electrons. On reaction it gives M moles. So if we apply Nernst equation for this, we get this electrode potential, that is at how the reaction is happening here. Mn plus is converting into M. For this, the electrode potential, that is equal to E naught, that is the standard electrode potential of Mn plus, that is converting into M, plus RT by NF ln of concentration of what is changing here, this concentration of Mn plus. So we are taking it here. Here the each and every term, that is this first E, this is known as the electrode potential, and this E naught, the E naught here, this is known as the standard electrode potential. The R here, R is nothing but gas constant. Remember the values of this gas constant also. You can, this are very useful in solving this problematic questions. The gas constant value is 8.314 joule per Kelvin mole. So units are also very important. They are also carry marks. And here F is Faraday, T is absolute temperature. So if T is given in degree centigrade, convert it into Kelvin and then apply in the question. Here Mn plus is concentration of species of Mn plus. So these are the, if we apply Nernst equation for this is the equation for that. So in this way you need to answer this question. The next question, a problem question from electrochemistry chapter. So it is given to calculate EMF of cell at 25 degrees centigrade. For the reaction, here chromium is converted into Cr plus 3 and Fe plus 2 is converted into Fe. So these are the electrode potential values for this conversion. So this E naught of Cr plus 3 to Cr, it gives minus 0.74 volts, and this Fe plus 2 to Fe gives minus 0.44 volts. And this you need to calculate EMF of the cell. So for this type of questions, The cell reaction is given directly in the question. First take the cell reaction, and the concentrations of these electrodes are also given. Here chromium is having concentration of 0.1 mole and Fe+2 is having concentration of 0.01 mole, and take the electrode potential values. Apply Nernst equation here. Since we need to calculate EMF of the cell, apply Nernst equation. For this, for calculation of electrode potential of this conversion of Cr to Cr+3, we have a E0 value of conversion here. We have a value of Cr+3 to Cr. In order to take this EMF by applying the Nernst equation, you need to write the Nernst equation for this electrode. See here, we are taking the conversion of Cr+3 to Cr, that is equal to E0 value plus 0.059. In this Nernst equation, if we apply the standard values of this R, T and F, we will get the value of 0.059. And here how we get 3? Because we are 3 electrons are involved in this conversion, Cr+3 to Cr. That's why N value is 3, and log to the base 10 and concentration of Cr+3. Already concentration is given, that is 0.1 m. If we apply all these values, we will get the value of this E of Cr+3 to Cr as minus 0.76 volts. Similarly, we need to calculate E of Fe+2 to Fe. Apply the concentration here, that is 0.01 m in the Nernst equation. You will get the value as minus 0.499 volts. To calculate EMF of the cell, you need to apply the formula E of RHS, right hand side electrode, minus left hand side electrode. We have this as right hand. We get this value Fe+2 to Fe as minus 0.499, and this conversion LHS value as minus 0.76. If you solve this, we will get with the complete value of 0.261 volts. In this way, you need to solve this problematic questions. So apply the concentrations clearly and solve the values. These logarithms are also very easy. These do not apply much calculation also, simply additions and subtractions. So don't confuse, this is the more scoring part of your exam. And next, from chemical kinetics, we have a topic of collision theory, right? So what is the question? Describe the silent features of collision theory of reaction rates of bimolecular reactions. Explain what is collision theory now. So what is collision theory? The collision theory of the rate of bimolecular reactions. The reaction molecules are assumed to be hard spheres. So write it in a point wise. So whenever if you write it in a point wise, this will be easy for correction also, and the points will be highlighted in your exam paper, in your answer key. And here the next point is, the reaction is postulated to occur when molecules collide with each other, right? When molecules collide with each other, there will be a chemical reaction. That chemical reaction with certain sufficient type of energy will give rise to products. So the number of collisions per second per unit volume of the reaction, that is known by collision frequency. They are asking for bimolecular elementary reaction. If we are taking bimolecules, that is two molecules, when A plus B collide, they form products. This collision theory requires activation energy, that is denoted by EA. This rate that is given by Z of AB, that is multiplied by e to the power of minus EA by RT. Arrhenius equation is applied here, and now all collisions do not lead to product formation, and the collisions with sufficient kinetic energy, that sufficient kinetic energy is known as threshold energy. The molecules which having this type of energy will give to products. Those type of collisions are known as effective collisions. Here, at this rate of this effective collisions is given by rate is equal to P of Z AB of e to the power of minus EA by RT. So in this way you can explain this collision theory. Wherever diagrams are necessary, you can use those diagrams also. And next, one more important question: what are the factors influencing the rate of reaction? Because the rate of reaction depends on four main important factors. This question is also very important for this 4 marks. So the factors that are influencing this reaction are concentration of the reactants. So this concentration of the reactant is directly proportional to the concentration of this rate of the reaction, that is the rate of the reaction which we need, that is directly proportional to the concentration of the reactants. If the concentration increases, the rate will also increase. Because of the number of effective collisions will be increased in the reacting molecules. Because of these collisions, the final products will be formed. And this nature of reactants. Next is nature of reactants, that is the reaction between ionic compounds are fast when compared to the reaction between the covalent compounds. This nature of the reactants is also very important. The main point is ionic compounds are very reactive compared to this covalent compounds. And next, why this ionic compounds involve in this rate of reaction very easily? Because there is easy bond breaking and bond formation when compared to this covalent bonds. And thus one more factor influencing this rate of reaction, important factor, is this temperature. This temperature is directly proportional to rate of reaction. When we increase the temperature, the collisions will also be increased in the given reaction, and there will be easy in the formation of products and catalyst. So this is also one of the important factor. This catalyst will increase as the rate of reaction, but this does not take part in the reaction. It just influences the rate of reaction. It just pushes the rate of reaction to form the products very fast. So these are the 4 important factors influencing rate of reaction. And from surface chemistry, you have mainly isotherms in surface chemistry. So question may be asked to explain what are these isotherms and a theory based on this isotherms, and you can also guess some problems based on this isotherms formulas. So what is this question? So how can the constants K and N of the Freundlich adsorption isotherm can be calculated? For answering such type of questions, you need to explain completely what is Freundlich adsorption isotherm. Here this isotherm states that X by M concentration to the ratio of the mass, that is equal to K of P to the power of 1 by N. Here K is the adsorption constant, P is the pressure, and N is the number of moles. So if you extend this formula and if you apply logarithm on both sides, that is log of x by m is equal to log K plus 1 by N of log of P. If you take it in a graphical representation, the slope, that is 1 by N, and on x axis you can see log P, and on y axis you can see log x by m, and here this log K acts as the intercept. So what is the question exactly asked? How can the constants K and N of the Freundlich adsorption isotherm can be calculated? So you need to find the formula to calculate K and N values. So after applying all this in a graph, you can easily say what is on x axis, what is on y, and what is slope and what is intercept, right? So after this you can tell how K is calculated. This K is the intercept, and N is the slope given. You can observe here the slope of the straight lines is given by 1 by N value, and the intercept, that is the log K value. From this we can get the values of K and N. So this is how you can calculate K and N values from this. So this you can expect this type of questions also. And next, from metallurgy we have different types of methods to in this process, metallurgy process, to separate the metals in their pure form. So one of the question I took for preparing for your final exams, just have some idea on all the methods which are there in your syllabus. In this slide I have took an example of this froth flotation method. So you need to explain what is froth flotation clearly. So what is this? So this method is used to concentrate sulfide ores, mainly sulfide ores. What we do in this process? In this process, a suspension of the powdered ore is made with water. What happens next? Next, a rotation paddle. You can explain it with the help of a diagram. A rotation paddle is used to agitate the suspension. So if we apply some type of rotation with this paddle in the suspension, there may be formation of bubbles, which is the froth. The froth is formed as a result of blown air from these paddles, which carries the mineral particles. So our required particles are present in this froth. The above serif froth collectors are we need to add collectors and stabilizers to this froth. What happens after that? If we add such type of collectors and stabilizers, they will stabilize the froth. What happens after stabilizing? The mineral particles which are wet by oil and gas particles are wet by the water. Those froth separated particles from this froth are wet by water. That is, the particles in this froth will be skimmed off, and the sulfide which is present in this, that is, for example, if we are taking in the ore, that is, it contains zinc sulfide and lead sulfide, we are using sodium cyanide. It prevents zinc sulfide from coming to the froth but allows the lead sulfide to come with the froth. Finally, we can separate this lead sulfide from this combination. In this way, this froth flotation is used. And next, from the coordination chemistry, you can guess questions like defining few terms such as ligand and coordination number, coordination entity, what is central metal atom or ion. So explain all the terms with the examples so that you can guess, or you can be allotted full marks. So let us see what is a ligand. What is this? The ions are the molecules bound to the central atom in the coordination entity. These are called ligands. For example, if we take a complex, so the molecules are ions bonded to the central atom. Which are bonded to the central atom? Such type of atoms are called ligands. For example, you can observe Cl minus. You can also observe H2O and NH3 as ligands around the central metal atom. You can also observe some alkanes, amines, molecules also. You can also see some macromolecules and proteins. Next, what is given? Coordination number. So what is coordination number? The coordination number of the metal ion in a complex can be defined as the number of ligands or the donor atoms to which the metal is directly bonded. See, observe, understand the formula. To which the central atom is bonded, in which the number of ligands or donor atoms which are directly bonded to the central atom, that defines the coordination number. For example, if we take a complex PtCl6 minus 2, here this platinum is bonded with 6 chlorine atoms. These chlorines are called ligands. So this platinum forms 6 bonds. The central atom here is the platinum. This forms 6 bonds with this chlorine. In such case, the coordination number of this platinum is 6. Similarly, in this complex also, here nickel is the coordinate central atom. The coordination number for this nickel is 4 because it forms 4 bonds with NH3. And next, what is given to explain coordination entity? It is the central metal atom or the ion bonded to a fixed number of molecules or ions that are nothing but the ligands. That is known as the coordination entity. Simply, for example, you need to write the complex, entire complex. The central atom is surrounded by the number of ligands. This complete description, that is known as coordination entity. Next, what is given to define central metal atom? So what is central metal atom? From the beginning we are saying central metal atom, right? So what is it? In a coordination entity, the atom or ion to which a fixed number of ions or groups are bonded. You can see here in this example, this platinum, it is bonded with 6 chlorines, which gives a definite geometrical shape, geometrical arrangement. That type of atoms present in the center of the complex, they are known as central metal atom. They can also be ions. So for example, it is K4FeCN taken 6. Here this Fe is forming 6 bonds with this ligand, with this cyanide ligand. So here this Fe is acting the central metal. In this way you need to define all the terms with examples. Examples are very important. And you can guess this type of question also. Explain the color and paramagnetic property of transition metals. So we need to explain how we get the color and paramagnetic property of this transition metals. I have already explained you in the last session about to remember the atomic electronic configuration of 1 to 30 elements. So if you remember this, you can easily answer any type of questions regarding this color and paramagnetic property and about this Bohr magnetons. So suppose if you remember this type of configurations for 1 to 30 elements, you can easily answer the n values, that is the number of unpaired electrons. Unpaired electrons you can easily calculate. For as per the question, you need to explain first about the color formation in transition metals. How color is formed in transition metals? The color is formed due to DD transition of electrons. It means there is a DD transition in the metals. What is DD transition? Electrons are excited from lower set of d orbitals. It means from ground state to higher set of d orbitals, that is to the excited state, by absorbing energy from visible light. See, from the visible light it takes energy, and after reaching to the ground excited state it will be highly unstable and it will return back to the ground state. During this return it emits the energy which has taken in its excitation. That during this emission there is a complementary color exhibited by the metal, that is the color of the ion. See, if, for your clear explanation, if an electron is present here and the ground state, for suppose this is the excited state, after taking certain energy it will absorb some amount of energy from the visible light, right? From the visible light, and it excites to excited state. In this excited state it is highly unstable, so it readily returns back to the ground state by emitting color, by emitting the energy absorbed in this excitation, that is it gives the respected color. This type of DD transition is responsible for the color of the ion. And what about this paramagnetic property? The transition element ions having at least one unpaired electron in d orbitals, they exhibit paramagnetic property. So here this n denotes the number of unpaired electrons. This is the magnetic moment. This is denoted by mu. This magnetic moment of this transition elements can be calculated by the formula under root of n plus 2, and where n is the number of unpaired electrons present in d orbitals. So this type of questions can be asked from this transition elements, and you can also expect few questions from this chemistry in everyday life. We have a question in this way: what are analgesics? So what are analgesics and how they are classified? Explain it with examples. These analgesics, they are used to reduce or totally abolish pain without causing impairment of consciousness, mental confusion, incoordination, paralysis, disturbance of nervous system. So simply they are used as the painkillers, and these can be classified into two types, mainly narcotic analgesics and non-narcotic analgesics. And these narcotic analgesics, these are most potent, it means they are highly powerful, and they are clinically useful agents causing depression of central nervous system. At the same time, they are acting as strong analgesics. For example, morphine and codeine. Define this and give an example. And this for non-narcotic analgesics also. These drugs are acting as analgesics, but they do not have no addictive properties. They do not have any addictive properties. For example, aspirin and ibuprofen. So these are used in mild headaches and pains. These are used as painkillers. So this type of questions, for every defined question you need to give certain example related to that question. And next you can expect a question. Write a note on antioxidants in food. So you need to explain what are antioxidants and how, in what type of chemicals they are present in our food. These antioxidants are important and necessary food additives, and these antioxidants help in food preservation. Mainly these help in food preservation by retarding the action of oxygen on food. If there is acting of oxygen on food, the food can be spoiled very easily. Because of the presence of this antioxidants, this can be stored. These antioxidants are more reactive towards the oxygens than the food material which they protect. So the most familiar antioxidants are butylated hydroxytoluene, that is BHT, and butylated hydroxyanisole, BHA. These type of antioxidants used for storing the food. This BHA addition to the butter increases its life from months to years. It means this cannot be spoiled very easily by adding BHA. And this BHT and BHA along with citric acid are used to produce more antioxidant effect. And we can also use this SO2 and sulfites as antioxidants for wine, beer, sugar syrups, and cut peeled dried fruits and vegetables, which can be stored for a long time. This is about antioxidants in our food. And for organic chemistry related questions, you can guess all the named reactions in your 4 marks answer questions. See, we have many number of organic named reactions. They are very repetitive in the previous year questions also. So I request you to observe this slide, save it, and practice all the named reactions, which are very helpful for your final exams. There will be a damn sure questions, not a question, questions for your final exam. You can guess this. Mainly you can see this type of questions in 4 marks and 8 marks. And remember these named reactions with their mechanisms mainly, because if you forget the writing of the product in that reaction also, if you remember the mechanism, you can write the product very easily. We have few named reactions like Wood's reaction. This is the general very important reaction. Next, Fittig reaction from haloalkanes and arenes. Wood's Fittig reaction. We have Williamson synthesis, and we have coal base electrolysis. This is also important repetitive questions. You can observe the number of years also here, this Williamson synthesis and coal base electrolysis. And we have famous important reaction, Raymond-Tiemann reaction. This is also very important. And we have aldol condensation. This is also very important. And we have cross aldol condensation. This is the very important reaction from this aldehydes and Cannizzaro reaction. You can guess all direct questions from this named reactions. Direct questions. And we have this H-Wizard's reaction, that is Hell-Wohlhard-Zelensky reaction. And next we have the small type of reactions, that is Gattermann-Koch reaction, Rosenman reaction, Stephen reaction, Clemenson's reduction, Wolff-Kirschner reductions. These are they don't require mechanisms, but they simply require the products. The remaining questions require mechanisms. And next from amines we have carbolamine reaction. This is for preparation of primary amines. Next diazotization reaction, Sandmeyer reaction. Next Gattermann reaction. We have coupling reaction also, and we have Hoffman bromide degradation reaction. This is also very important. And this Friedel-Crafts alkylation and acylation. These are also very important reactions. So take time and practice this reactions with the help of mechanisms, and you can easily get 4 marks very easily. If they are asked in 8 marks questions, maximum they can be asked with the help of mechanism in long answer questions, and they can also be asked in this way to find the final products of reactions also, if it is asked in 8 marks. So there is a damn sure question for 4 marks. Let us take one of the reaction as an example to how to write in your exam, that is aldol condensation. So what is aldol condensation? See the question, this is from aldehydes. You can apply this aldol condensation in aldehydes and ketones. You can apply this reaction for both aldehydes and ketones. So let us see what is this reaction clearly. When aldehyde and ketones having at least one alpha hydrogen. So write the statement clearly, what is this aldol condensation mainly? When these aldehydes or ketones which we take in the reactant, they are having at least one alpha hydrogen. It means, what is alpha hydrogen? The main group, either it may be aldehyde group or keto group. Aldehyde group or keto group. If there is any alkyl compound attached to it, for example, if it is for aldehyde, if it is in this way, or if it is for ketone, if it is in this way, the carbon attached hydrogens, here also the carbon attached hydrogens to the main carbonyl group, those are called alpha hydrogens. This carbon attached hydrogen, these are also known as alpha hydrogens. These hydrogens are also known as alpha hydrogens, and these carbons are known as alpha carbons. Here also this is also alpha carbon, this is also alpha carbon. If any compound containing alpha hydrogens, any aldehyde or ketonic compound containing alpha hydrogens, when these are treated with dilute alkali, it means a dilute base. Here we are taking the base as sodium hydroxide. Then they form beta hydroxyaldehydes. The product formed here is known as beta hydroxyaldehydes. Since there is a hydroxy group, that is represented as all. Mainly aldehydes are involved, so it is aldol. The product is aldol. Or beta hydroxy, if we use ketones in it, beta hydroxy ketones, it means if ketones are involved, the product formed is beta hydroxy ketones. and the product is named as ketol. It means there is presence of hydroxy group with a ketone group. This type of reactions are known as aldol condensation. You can see example here, when 2 moles of ethanol, it means 2 moles of CH3CH4, when it is treated with dilute NaOH, what happens? There is a formation of beta hydroxyaldehyde. See here, there is a aldehyde functional group. The carbon attached to this aldehyde group, that is known as alpha carbon. The next to the alpha carbon, that is the beta carbon. The hydroxy group is formed at this beta position. That's why it is known as beta hydroxyaldehyde, because of the aldehyde group present in it. That's why the product formed is beta hydroxyaldehyde, that is aldol. If we use ethanol, 2 moles of ethanol as reactant, the product is 3-hydroxybutanol. So this is the aldol. If you react it further on heating, there is a loss of H2O. So we can lose one hydrogen from here and OH from its adjacent carbon. So we will get but-2-enol. So this is aldol condensation product. In this way you can write aldol condensation. So I have explained you through the reaction, but when it is asked to write the mechanism, you need to write how 2 aldehyde groups are attached. Condensation means mainly formation of CC bond. How a new CC bond is formed between 2 aldehydes, what are the steps involved in it, and how a new condensed product is formed after heating. So explain in this way when it is asked to write mechanism. When it is asked to write for ketones also, write it in the same way, and the product is beta hydroxy ketone. This is about aldol condensation. And if it is asked about cross aldol condensation, in aldol condensation what we did, we took 2 same moles of the reactant, same moles of aldehyde, same type of aldehydes and same type of ketones that we are taking in aldol condensation. When it comes for cross aldol condensations, we are taking the aldol condensation reaction between 2 different aldehydes or between 2 different ketones, or the reaction between an aldehyde or a ketone. This type of a crossed aldol condensation is taking place when we change the reactants. That is, you can see here the reaction between CH3CHO and CH3CH2CHO. The same mechanism is followed here, and the products formed will be the cross aldol products. And here also the same reaction. If you take the different types of aldehydes and different types of ketones, or a reaction between aldehyde and a ketone, those type of reactions are known as crossed aldol reactions, crossed aldol condensation reactions. So try to practice all the named reactions in this slide and remember them. And this is all about the short answer questions. Thank you for joining.